Yes, ma'am.
Thank you. Now, if you have any WhatsApp group, ask your friends to join the meeting, please. We'll wait for 1 minute and we'll start the session. Okay, let others join the meeting. We'll start the session. What we were discussing in the previous class now. Hope my screen is visible.
Yes, ma'am.
Kindly confirm. Is my screen visible?
Yes, ma'am.
We were discussing about PGP, right? So in the previous class, we were discussing about the overview of the PGP. In today's class, we'll be seeing the configuration, the example, PGP configuration examples. Right? So see you. We have two autonomous systems, right? What are the numbers? Autonomous system 65101 and 65102, right? So 65101, it contains three routers, R1, R2, and R4. Likewise, we have two autonomous systems, 101, 102. 101 contains three routers, R1, R2, R4, and R2 contains one router, that is R3. So inside 65101, we'll be using EIGRP. Okay, it is an interior gateway protocol, which will be in order to route the packets between R1, R2, R4, we'll be using interior gateway protocol. Okay, so PGP will be configured for external communication. So from one autonomous system to another autonomous system, we'll be using PGP. Fine. So between these two autonomous systems, we'll be using router gateway protocol. Right. So R1, there are two neighbors. So how many with the help of, if I'm taking R1 as an example, R1 is having two neighbors. Okay, two neighbors are configured. Which are the one? One is, which are the neighbors? See, one is R4, another one is R3. So R4, it is having the ID 10.1.1.2. Okay, it is within the same autonomous system. So it will be using IPGP. It is an IPGP neighbor. Fine. This one is the IPGP neighbor. Other one, what is R3? R3, it is working on this IP address, that is 202.165.201.2. Okay, so see here, it is a different IP address, right? So it is a part of autonomous system 65102. So for this, we'll be using ePGP, exterior PGP. So it is exterior PGP neighbor. Okay. So R4 will be configured here. R4 will be configured with only one neighbor, that is R4. R2 will be configured with one neighbor, that is R4. R4, even R4 has two neighbors, that is R2 and R1. Both are belongs to the same autonomous system. So it will be using IPGP, interior PGP. So this is how the relationship between the neighbors will happen. So either we'll be using IPGP relationship or we'll be using ePGP relationship. So PGP will be configured with either IPGP will be on, say for example, if I'm taking R3. So on R3, PGP will be configured with R1. R1 will be a neighbor, right? So which is neighbor at 209.165.201.1, okay, which is part of autonomous system 101. Okay, so it will be connected to this 201.2 with an autonomous system 65101. So this forms an ePGP relationship between these two autonomous systems. So R1 here, R1 will be here. It will be a gateway router. So why we say it's a gateway router? It will be connecting internal routers in autonomous system 65101 with the help of IPGP. And also at the same time, it will connect to the external autonomous system 65102 using ePGP. So this setup will allow you to have internal routers. They can able to exchange the routes via IPGP, and also even it will be connected. So we can even ensure external connectivity with the help of ePGP. So that is what given here. Okay. Any doubts?
No, ma'am.
So see here, we have in this topology, we have two autonomous systems, right? So what are the autonomous systems? 65100 and 65000. These are the two autonomous systems. So 6510 has one router R1, and 6500 it is having two routers R2 and R3. So there is a WAN link, as you can see here, there is a WAN link. WAN link, it operates on 209.165.202.128/30. So it will be connecting R1 and R2. So inside autonomous system 65000, R2 and R3 are connected using the subnet. Okay, so what is the subnet that is used? 172.116.23.0/25. Okay, whereas in R1, we configure PGP with autonomous system number 65100. Okay, it is a neighbor. Uh, which is the neighbor? Neighbor is R2. R2, it works on different IP address, right? So when you see R1, R2 works on different IP address. So which belongs to a different autonomous systems, right? In this case, we'll be using ePGP, exterior gateway protocol session. So if I'm taking R2 an example, R2 PGP is configured with autonomous system number 65000. It has two neighbors, right? One is R1, another one is R3. So R1, it works on this IP address, and R2, which works on this IP address. So as you can see here, it, it is two different subnets. So one will be using ePGP. So this will be R1 will be ePGP neighbor, and R3 will be IPGP neighbor. Okay, based upon the subnet mask, the neighboring will be allocated. Fine. So it peers with R2 using this IP address. Fine. So R2, how it will advertise? It will advertise with the help of this IP address 192.168.2.2/32, and also 192.168.22.1.24. So how R3 will be advertising? R3 will advertise with the help of these two things. So for verification, we'll be using commands like show IP, TGP, summary. Okay. In order to check the neighbor states, we'll be using this. And also show IP, TGP. It is used to confirm the routes which are being received and which are being advertised. For that, we'll be using this command. And we have one more command, that is ping as well as trace route. Okay. So what is the purpose of ping? In order to check the connectivity, trace route, how many routers are there. So in order to verify the connectivity across the AS boundaries, we can use these two commands. Okay. So this helps us to demonstrate how to configure the basic EPGP between different autonomous systems, and also to configure IPGP within the same autonomous system. So we can verify the connectivity with the help of these three commands. Fine. Okay. So we'll try to configure and verify in EPGP session. Fine. So in this example, we are going to configure an external PGP connection between the routers R1. So R1, it works on autonomous system 65100, and R2, it is a part of autonomous system 65000. Okay. So on R1, the PGP process will be started with router PGP 65100. Then we need to provide the neighbor. Who is the neighbor? So for that, we'll be using the neighbor command. So that then the neighbor R2 will be configured. So it should be configured at the IP address here. This is the neighbor, right? R2 will be configured with 101.209.165.202.130. So it is a remote address. So how to configure that? We'll be saying the neighbor. This is actually the neighbor. So it is a part of remote autonomous systems, and the autonomous system number is 65000. Fine. So this is how we'll be configuring the neighbor. We'll be saying R1 is part of a autonomous system 65100. Okay. And also the neighbor, there is a neighbor for R1 that works on this IP address. Okay. It is a part of autonomous system number 65000. Okay. Now we need to configure R2, right? So R2, it belongs to autonomous system 65000, right? That is what the first command. Okay. It is started with the router PGP 65000. Who's the neighbor? Neighbor is R1. So R1, it works at 209.165.202.129. Okay. So this is how we'll be making the configuration between R1 and R2. Fine. So see here. Fine. So this IP address will be mentioned there. Fine.
Yes, ma'am.
So once both the sites have matching neighbor configurations, what we have to do, the EPGP session will be established across the WAN link. Right? In order to verify the session, which command we'll be using? In the previous slide itself, I've told you. Which command we'll be using? Show IP PGP summary, right? In order to verify the session, we'll be using show space IP space PGP summary. It is used on, in this example, it is used on R1. So what is the output? This is actually the output of that command. So PGP router identifier is provided. So which is the identifier? This is the identifier. It is a local autonomous system. It is a part of 65100. Yes, it is a part of 65100. Yes. And the neighbor addresses are provided. So which is the neighbor? This is actually the neighbor. So which is in the autonomous system number 65000. The session has been 1 hour and 20 minutes. What is the uptime? It is shown here. It is updated in up or down time column. So the number of prefixes, how many number of prefixes are received? So that is 0. So prefix received is 0. So meaning there is no network have been advertised it. So this will confirm that the ePGP session is been between R1 and R2. Successfully, it is established, even though the root exchange it is provided. Okay, so this will be verifying that any doubts, ma?
No, ma'am.
Now we'll how to verify an ePGP session. Okay. So after configuring ePGP neighbors, we'll be using the command show IPGP IPPGP summary. So in order to verify the session, right? So this is actually the output. In the previous slide itself, we have seen. So the autonomous system, the router R1, it belongs to autonomous system 65100, and it is having a neighbor. And the uptime, this is the uptime. The routes are not being shared as of now. Okay, so that is what shown here. Okay, the output, uh, uh, the neighbor, who's the neighbor, what is the IP address, the version port. This indicates the version being used between this router and the neighbor, right? And autonomous system 65000. The neighbor's autonomous system number will be provided. Okay, so this neighbor, it belongs to 65000. So how many messages are received? The number of PGP messages received from the neighbor since the session started is 91. Okay, how many messages sent? It is 93. So the table version, it is provided here. The table version, PGP routing table version, the last sent to the neighbor, the version number is 1. Okay, in queue, how many messages? 0. Out queue, how many messages? It is 0. So the messages from the neighbor will be waiting to be processed, right? Always it will be placed in the queue. Okay, so the in queue and the out queue. So the uptime and downtime, the amount of time the PGP session has been in its current state after the establishment. That will be provided in the up down time. Okay, what is the state? This displays the current state of the PGP session. Okay, so it can be idle or it can be active, open sent, open confirm, established. Okay, so when it is established, it means the PGP session is fully will be in the up condition. Fine. And we have a prefix received. Once the state is established, in the established state, the number of prefixes or number of roots, how many roots that has been learned from the neighbor, that will be provided here. Okay, so if the state is established, the prefix, and if the prefix are received, EEPGP session is fully in the running condition. Fine. Say for example, the EGP the EGP session is established, but there is no prefix. In that case, 0 will be provided. So the PGP session is established successfully, but there is no routes exchanged yet. In that case, 0 will be provided. So what will be the state? The state shows established, but the prefixes will be set to 0. So no routes are being shared. The neighbors has not advertised any networks. In that case, it will be 0. Okay, connectivity with the router will be there, but no routing information is being shared between R1 and R2. Okay, so if the PGP ePGP session is established and the prefix are learned, in that case, the difference is that this column, the prefixed column, will be showing one or more prefix. So this will be indicating that the neighbor has advertised certain networks with the help of the network command or through redistribution. So the local PGP router will be installed those prefixes into its PGP table. Okay, so this will be verifying that not only the session is working, but also there is some exchange between autonomous systems that is also successful. Fine. So what is the command which is used to the command is show IP PGP neighbors. Okay, so to verify and troubleshoot the PGP session, we'll be using this command. Okay, show IP PGP neighbors. So this will be displaying the neighboring relationship status, capabilities, what are the address families they are using, what are the session statistics, everything will be displayed there. Okay, so the PGP neighbor, so which is the PGP neighbor? In the previous case, it is a 130. Okay, which works in the autonomous system 65000. So it confirms it is an ePGP session, right? So here, this is actually the neighbor, which is part of autonomous system number 65000, right? And what is the remote router ID? So the remote router ID in this case, it is 192.168.22.1. This is actually the remote ID. Okay, the session established that a session is up and it is stable. Fine. So the timer details here, we'll be having the PGP router identifier. The router identifier will tells the IP address of the neighbors, okay, the speakers. And the local autonomous number says what are the autonomous numbers, okay, the remote autonomous system numbers, the local routers, autonomous system numbers, okay. And we have a table version and the routing table version also. That's what we have seen in the previous example itself. So what are the messages that are being last read and uh, written? How many messages are there? What is the hold time? What is the keep alive interval? Everything will be used to ensure both the routers monitoring the session tables. Okay, so we have neighboring capabilities. So we can route refresh capabilities there in order to support dynamic updates without resetting it. And also we have address family, okay, that can be advertised and received. And we can track control messages. Okay, so the control messages for opens, the control message will be 1. For notifications, okay, we'll be using 0. Okay, keep alive, it will be 91. Okay, router refresh, it will be 0. Right, so the total messages exchanged and received can be part, it is also a part of the PGP summary table. Fine. Have messages received, messages sent, the table version, in queue, out queue, uptime, state, and the prefix. Fine. Default minimum advertised interval will be 30 seconds. Fine. So in the session information, it will be confirming whether the routes are being exchanged between the neighbors. So the output will confirm the ePGP session between the router and the neighbor is up stable and whether it can able to exchange the routes. Okay, so it supports timers, message statistics, capabilities. So healthy, in order to provide the healthy and functional PGP pairing, this summary will help us to understand everything. Fine. So this is an example for show IP PGP neighbors. Fine. So this is actually the neighbor autonomous system number, which is part of the autonomous system number. It is a remote autonomous system number. What are the versions? The last message read, last message return. Okay. Hold time is 180 and the keep alive interval, it is 60. Okay. So the neighbor sessions, one is active. Right. What are the capabilities? Okay. Statistics. Fine. So notifications, how many notifications shared, how many updates are being shared, what is the keep alive message, route refresh, how many messages are being sent and received. Okay, so that is what it is shown here. Okay, this not only confirms the session, ePGP session between the routers, but also it confirms what is the statistics, what is the capabilities, whether it is a healthy session, whether it is functioning. Everything we can monitor with the help of show IP PGP neighbors. Fine. See, in this example, we have used another command, show IP PGP neighbors. Okay. In that, we can provide the IP address. So this is the IP address provided here. Okay. In order to examine the PGP peering details with a specific neighbor, we can use this particular command. Okay. Show IP PGP neighbors. You can give the IP address of that particular neighbor. So the visibility, it will be, we can even provide the options. There is an option to provide the visibility into the rules, policies, and statistics. Okay. So what are the things that will be? So this is actually the output of that message. Okay. So the first one is advertised routes. So it will show the routes. This router is advertised to the neighbor. So this will be useful for checking the PGP policy, output PGP policy. Okay. It displays the routes advertised to the PGP neighbors. And the next one is dampened routes. So this will be displaying suppressed routes. Okay, that is dampened routes from the neighbor. So this will be applicable only for the ePGP peers. Okay, so that it helps to monitor the route flap damping. And the next one is flap statistics. So flap statistics, it will be showing the flapping routes. So flapping routes which are being learned from the neighbor. So helps to identify unstable prefix. That's what we'll be saying as flap routes. Right? And you have more options, options. In, these are part of more options. In more options, starting one will be the path. Paths says it displays the autonomous paths that are being received from the neighbor. Okay. So in order to avoid the loop prevention and also path selection verification, we'll be including the paths. Okay. And there is another one which is called as a policy. So policy will be applied to the neighboring policies. So what are the neighboring policies? Whether filtering is required, whether routes map is required. So all those things comes under policy. So the third one is received. Okay. So received, it displays all the information received from the neighbor. So including the updates, everything will be displayed. Okay. And you have a final option that is received routes. So the received routes, it shows the actual routes that are being received from the neighbor. Okay. In order to validate the inbound policy. Okay. The next one is routes. So the routes, it shows the routes that are being learned from the neighbor. Okay. And also it is installed in the PGP table. That will be part of the routes. Okay. So show IP PGP neighbor. It is a troubleshooting tool which helps us to check outbound advertisements, inbound receive routes, policies together with the route stability, whether it is a flapped routes or dampened routes. Okay, for verifying the PGP session, health and policies will be using this command. Okay, any doubts? Any doubts?
No, ma'am.
What about others? Students, are you there in the meeting? Can everyone please confirm? Shivam, Shujit. I don't know what happened to rest of the students. Out of 50 plus students, only 2 are there in the meeting, physically present. Okay. Now we'll see uh, how to configure and verify an IPGP session. Okay, the topology overview. The autonomous system number, you have two autonomous systems, 65100 and 65000. So 65100, it contains router 1. So router 1 uh, with loop, uh, loop, loop back addresses. So we have two loop back addresses, that is 209 209.165.201.1/32 and 209.165.200.225/27. Fine. And autonomous system 65000, it contains routers R2 and R3, right? R2 and R3, which is also having loopback addresses. Okay, R2 is having two addresses, that is 192.168.2.2/22, sorry, 32, and 192.168.22.1/24. Likewise, R3 has two address, that is 192.168.3.3/32 and 192.168.33.1/24. Okay, so there is a WAN link. WAN link, it connects to R1, right? R1 and R2. So for connecting R1 and R2, we have a WAN link, right? So this is having 209.165.202.128/30. So now we need to configure and verify the IPGP session between R2 and R3. So this is what our RA. Why? Because this is interior broad PGP. That's the reason we need to verify the session between R2 and R3. So how to between different autonomous systems, we'll be using BPGP. Between the routers in the same autonomous system, we'll be using IPGP, right? So R2 and R3, it is part of the same autonomous systems. So we'll be using IPGP session here. So in order to connect to these two routers only, we'll be using EPGP. So these R2 and R3, it is part of the same autonomous system. That's the reason we are using IPGP. So how to configure IPGP on R2? Okay, so that can be done with the help of the command router PGP 65000. So the router PGP, what is the autonomous system number? And the next line, we need to say the neighbor. So which is the neighbor? Neighbor is 192.168. The IP address you have to provide. So 168.3.3 is the neighbor, okay, which is a part of the same autonomous system number. So what is the autonomous system number? 65000. So now R2 establishes IPGP connection with R3 with the loopback address 0, that is 192.168.3.3.32. Okay, so the loopback addresses will be preferred to ensure the stability. So not physical interface, it is a dependent one. Okay, so in order to add another neighbor, again we'll be using the same command, neighbor 192.168.33/1. Or else if I want to update it, okay, I can say that neighbor 192.168.3.3. So I need to update the source. Update source. Which one you have to update? It is a loop back address 0. This way also you can provide. Okay. So now I need to configure IPGP on R3. Right? We have did on R2. Now we have to do it on R3. So what is the command? First command, that is router PGP 65000. Right? And also we have to say the neighbor. So the neighbor is 192.168.2.2. Okay, remote as 65000. Okay, so now we have to update the source. That can be done with the help of neighbor 192.168.2.2. Update source, loopback 0. So R3 will establish IPGP session with R2 using the loopback address 0. So how to verify that? So this can be verified with the help of one command, that is, what is the command? Show IP PGP summary. This is for the verification. Okay. So whether it is established, how many number of prefix that are being received. Okay. So you can even check the detailed session. Even that can be, you can verify with the help of show IP PGP neighbors. So this will confirm the session timers, capabilities, policies, everything. Okay. So if you're giving show IP PGP, it will be verifying whether the loopback address from R2 and R3 are being in the PGP table. That's it. Okay. So summary will be giving detail. The neighbors will be giving more details, the session timers, capabilities, and policies. Okay. So R2 and R3 IPGP will ensure root exchange, which is inside 65000. Fine. So the loopback interfaces, it will be making PGP sessions. Fine. So we can verify with the help of neighbor status or the routes learned and advertised, stability of the session, everything can be verified. Okay, so in this topology, R2 and R3 are in the same autonomous system. That's the reason we have configured with IPGP between these things using the loopback addresses. Okay, so once after defining the neighbors and updating the source, we can verify with the help of show IP PGP summary, or else you can go for show IP PGP neighbors. Or if you want to need a simple example whether the sessions are established, in that case you can go for show IP PGP. Okay, so it will tell you whether the sessions are successfully established. It will tell the confirmation whether the IPGP session is up, whether routes are being exchanged properly within the autonomous systems. Fine. So this is what the command. So and R2 router PGP 65000 neighbor. This is actually the neighbor. Okay. So we need to update the source. This is for R3. Okay. And also we are telling the neighbor. Fine. So both the neighbors are within the same autonomous system. IPGP session will be established. So the direct physical IPs will be used as neighbors. What are those links? These are the links. Fine. So how to verify? It can be verified with the help of show IP PGP summary. So see here, show IP PGP summary, or else you can go for show IP PGP neighbors. Fine. So on R2 it is being used. Fine. So it will be displaying the router ID. So what is the router ID? It is 192.168.22.1. This is for R2. Fine. This is part of R2. So it is a part of autonomous system number 65000. So it is providing a neighboring table. So which are the neighbors? These two are the neighbors. Fine. So it is part of autonomous system number 65000 and 65100. Fine. The state will tell you whether it has been established, and the prefixes will tell you how many things are being uh, exchanged, how many routes are being exchanged. Right? So this will confirm the first one. It is confirming the IPGP session is up and it is working. Right? So in order to verify with show IP PGP neighbors, it will show the detailed neighbor information. So what is the IP address of the neighbor? Right? So what is the remote autonomous system? What is the PGP version? What is the PGP state? Whether it is healthy, whether it is stable, everything will be provided. Okay. So IPGP can be configured between R2 and R3 inside the same autonomous system, that is 65000. Fine. It can be verified with the help of two commands: show IP PGP summary and show IP PGP neighbors. Okay, so this is for quick statics, and also it will tell you the prefix, how many prefix that are being exchanged. So this will give you the detailed neighbor information. That is the main difference between these two things. Okay, so we have configured IP PGP between R2 and R3. We have checked with the help of these two commands. Fine. It is verified. Verification is done with the help of these two commands. Any doubts?
No, ma'am.
So the network, network number. So this will inject a route from the IP routing table into PGP table. So they can be advertised to PGP peers. Okay. So this is actually the command. What is the command? This is actually the command: network space network number. Okay. So from the IP table, that will be injected to the PGP table. Fine. So network number, it will be identifying the IPv4 network that is to be advertised by the PGP. Okay. Together with that, we can even provide the mask together with the network mask. But this one is optional. Okay. So this will be providing the subnet mask for the advertised network. Okay. So if I'm not, since I've told you it is an optional one. So if it is omitted, the PGP will be using the default classful mask. It is not classless mask. It will be using classful mask. Okay. The network, if I want to use this, the network must already existing in the IP routing table. Okay. It can be via, it can be learned via static table or connector or with the help of IPGP, anything it could be, but it should be already available, already exist, and it should be in the networking table, or else the PGP will not advertise it. Okay, so it will also allow granular control. Okay, with the prefixes which are entering the PGP. So how it can be done with the help of router PGP 65000. Then we need to use the command, right? So router PGP. This is an example for that. I'm using the network command. Network. What is the IP address? I'm taking the random IP address and I'm providing the mask. Okay, so 255.255.255.0. Classy IP address. Fine. Then I can advertise another network 33.0. And the mask is the same one. Classy IP address. So this I'm doing it on R2. So R2 will advertise the LAN subnets. So these two LAN subnets into PGP. So these networks will be propagated to IPGP as well as to EPGP peers. Okay. Even it can be verified with the help of show IP PGP. Okay. So this confirms the prefixes in the PGP table. Fine. And even you can use show IP PGP neighbors commands as well. Fine. The neighbor, or even you can provide the IP address of the neighbor in order to get the detailed information. So the network command, it will control with local routes. So the local routes which are part of the networking table will be injected into the PGP table. Okay, so only intended prefix will be advertised. So it can be verified with the help of show IP PGP or show IP PGP neighbors, or even you can specifically use one IP address. Okay. So what is the purpose of a network command? In order to inject the IP network, IPv4 networks from the routing table into the PGP table. Fine. So what is the purpose of advertising the networks in PGP? So purpose of network command. So network command, it will determine which network the router advertises into the PGP. Okay. So it does not enable the PGP on the interface. Rather, it tells the PGP which prefixes are to originate. Fine. So it should include all the networks in the autonomous system, whatever that you want to advertise. So it is not limited to directly connected networks. So the networks, what is the limitation? What is the condition? The network must already should be there in the routing table, or else it cannot be advertised. So PGP4, it supports classless prefixes as well. Okay, so before versions, it uses only classful. So PGP4, it also supports classless prefixes. You can advertise with the help of subnets and even with the supernets. So if the mask is not specified, what will happen? The classful networks will be advertised. So at least one subnet of that network should be there in the routing table. Fine. So what is the difference between, we have used two commands, one with the help of a neighbor, right? Then another one with the help of a network. So we have used two commands, right? So what is the purpose of neighbor? Neighbor command, it tells where to advertise. Okay, what is the PGP? Peers. A network command, it tells what to advertise. Okay, what are the prefix? So the network prefixes will be advertised and neighbor peers will be uh, sending the routes. So peers to send routes. Okay, so network will have a mask option. So it can even use CIDR. What is CIDR? What is CIDR, ma? You would have studied in computer networks itself. What is CIDR?
It is classless interdomain routing. It's used
It's
for IP
classless.
addressing and to allocate IP addresses. Like
If I
just
want to separate a LAN into multiple logical networks, that is subnets, we'll be using CIDR notation, right? So physically, it will be looking like one single local area network, but logically, it will be separated into multiple subnets. So in that case, we can go for CIDR, classless interdomain routing. Okay, subnets and supernets support. So what is the purpose of a network command? Network command determines which network the router will advertise. Fine. So this command does not activate PGP on the interfaces. So what it will do, it tells the PGP which prefixes should be originated from the router. Okay. So the list of networks you configure, all these things must be included in all the prefixes that you want to advertise across your autonomous systems. Okay. Just those locally connected. So from the PGP4 onwards, it supports classless prefixes as well. We can advertise both subnets and supernets with the help of a mask parameter. So if I'm not specifying the mask explicitly, the PGP will announce the classful major network. Fine. So for that, at least there should be one subnet exist in the routing table. Fine. So this is actually the difference between the network and the neighbor. Now we'll see exact match requirement. How the exact match requirement start. So when using the network command in PGP with a mask, the exact prefix, that is address plus the subnet, should be existing in the router's routing table. So the entry in the routing table, if it is not having that exact match, it is not exactly matching, the PGP will not advertise it. So the reachability check must be there. So before you're advertising, the PGP will be verifying whether that route is present and whether it is reachable in the routing table. Okay, if it is not reachable, it will not be advertising to the neighbors. So suppose in this example, they've given if you want to advertise 192.168.0.0.0/24. Okay, so if you mistakenly configure with a command that is network, this is the network ID. So I'll write it network 192.168.0.0. Okay, and the mask is 255.255.0.0. So if you mistakenly configure it as network 192.168.0.0, the mask is given. So the PGP, what it will do is PGP will look for 192.168.0.0/16. So 8 plus 8, 2 octets we have used /16 in the routing table. So the router is having, I have a routing table. In my routing table, there is a match, but it is for 192.168.0.0/24, not for 16. Okay, so you have given these information. By default, the mask will be taken as the 2 octets. So it will be /16. It will be exact max should be there. So it will be looking for /16. But what is there in the network table? Networking table /24 is there. Okay, forwarding table has /24. Okay, so the PGP will not advertise the network. Why? Because there is not exact match is not there. Okay, so if you want to advertise 192.168.0.0.16, you have to ensure the entry should it is also there in the routing table. So if the routing table contains smaller subnets like /24 entries, the PGP will not announce /16. Okay, in order to solve this problem, you can configure a static route to null. Okay, for that you have to use IP route 192.168.0.0.0. What is the mask? Null 0. Okay, so this will be creating an exact /16 entry in the routing table. Then the PGP can recognize it and it can advertise to the neighbors. Okay, so the network command, it defines what the network should be advertised, what network prefix to be advertised. Okay, so the neighboring commands where it should be advertised, where those prefixes should be advertised. That is the main difference, right? So the PGP can only advertise the prefixes which are already existing in the routing table with an exact match. So if it is not matching, it will not advertise it. So if you want to do that, advertise and aggregate, in that case, you have to use a static route. Okay, that is null 0. So that the PGP can find and it can announce it. Fine. Any doubts, Kana? Any doubts? Let continue. So 65 autonomous system 65000. It is having the router R3 and R2. So R3, in this example, R3 is advertising. Okay, so R3 is advertising the network. So which network it is advertising? 192.168.33.0. And what is the mask? It is class C IP address. So 255.255.255. So which one it is advertising? It says 133.0/24. So the loop back and Ethernet interfaces will be configured on R3, right? So the PGP peers will be exchanging the routing information with the help of the WAN link. So this is actually the configuration of R3. So router PGP 65000 and the net with the help of a network ID, we have given the mask. So this will inform the PGP in order to advertise 192.168.33.0. If it is already there in the routing table with the exact prefix or the mask, it will advertise. Okay, so how it can verify? It can be verified with the help of show IP PGP. Okay, so this is actually the output of that command. So the PGP table version number, what is the version number? It is 2. The local router ID, this is actually the ID. These are the status codes. So yes for suppress, D for DAM, H for history. Okay, I internal, R RIB failure. So this shows the history and origin codes. So whether it is IPGP or ePGP or incomplete. Okay, and the validation, it is shown here. Okay, so which are the routes that are valid? So it will be provided with the help of star greater than symbol. Okay, so and you have a valid routes. The valid routes will be star equal to. In this case, we can take this is actually the valid route. Okay, so the next one greater than equal to, this will be the best path. Okay, so whichever the path that is being selected, that will be identified with greater than equal. Okay, so what is the network advertised? 192.168.33.0. This is actually the advertised network. What is the next stop? There is no next stop. Okay, it is, this indicates the route is logically originated. Sorry, locally it is originated. It is originated from the R3 router itself. It is a local originator. Okay. So what is the default weight? The default weight is 32768. Okay. So this is a Cisco's default weight. It is a locally originated message. For that, we'll be providing this weight. So I means it is origin code. So we have seen here, right? So where it has been originated. So it is origin. So the root was learned via IPGP. So IGP, Interior Gateway Protocol. And it is injected into PGP with the help of a network command. That is what provided you. Okay, so the PGP can advertise the network if it is finding an exact match in the routing table. Okay, so this particular address, that is 192.168.33.0/24, it is already there in the routing table. So the PGP could be able to advertise it. Okay, so even we can verify with the help of show IP PGP. So this will confirm that the route is valid and also whether it is the best one or whether it is advertised to neighbors. So all the detailed information can be provided. Okay. So what is the version? Just now we have seen this is actually the version. This is the IP address, the router ID. Okay, who is the PGP speaker? That is what provided here. So you have status codes. So the status codes star will tell you whether it is whether the next hop is valid or not. Okay, greater than symbol will tell you it is the best path. Okay, so you have other codes as well, SDHR. So all these things are the status codes. Okay, different conditions can be provided. So what is the purpose of I? It has been originated from IGP and it is part of a routing table and it is being given to the PGP with the help of a network command. Okay, so if instead of if E is provided, then it is originated from EGP. Okay, so if it is question mark, it is unknown or redistributed. So these are the three things. Okay, in this example, it says star indicates the next hop is valid and greater than symbol indicates it is actually the best path. Fine. So this is the network ID. Next hop is connected. It is a locally originated one. That's the reason it is 0.0.0.0. And the metric is 0, the default. Okay. And the local preference is not given, not shown here. And the weight is 32768. It is a Cisco's default locally originated routes. Okay. And the prefix, which is having the highest prefix. Okay, that is 32768. And the path is I, originated from IGP. Fine. So now we'll see the next column. Okay, so network command. So we are using the network. Okay, network column. So that is this can be advertised. The prefix can be advertised. Okay, so instead of the next stop 0.0.0.0, so this will tell us the route was locally originated. Okay, so locally originated from router R3. So if you have another IP address, the route was learned from some other IP address, some other router, the next hop. In that case, uh, the next hop value will be the IP address. So what will be the metric? Instead of 0, if PGP metric, if it is multi-exit or discriminator or MED, that will be the matrix part. Okay, so the value 0, it means that it is a default one. It is not manipulated. Okay, and the local preference is 32768. It is the highest preference for the router. Okay, why? Because it is the best one and it is just now we have seen, right? So this is the best path and the next stop is valid. That is being indicated already. Okay, so the higher value will be given the more preference when choosing the best path. Fine. So that is actually the weight. Fine. This is goes uh, the default value. The highest preference is given, and I indicates IGP. Now we have seen the three different conditions, I, E, and question mark. Okay, star indicates it is a valid path, and greater than symbol indicates it is the best path. Okay, so R3 is originated from 192.168.333.0. Okay, the next hop is it is not the next hop. Why? Because it is locally originated. So this is a valid path, and this is the best path. Fine. Now we'll see, uh, we can examine the PGP table output analysis. So network, next hop, metrics, local preference, weight, and path, right? So this is actually the code that is given. So what is the network? This is actually the network, the destination network prefix that is being advertised or which is being learned in the PGP. Next hop, the router R3. Uh, it means this router R3 is the originator of the route, that is locally originated network. Okay, so the metric is 0. So 0, there is no MED. So MED is used to tell you how external autonomous routers can enter an autonomous system, right? So here MED value, multi-exit discriminator value is 0. Okay, and the local preference value, the default value is set. Here the value is not provided. So you can even give the highest value, that is 32768. This is the default local preference for the locally originated routes. And there's a weight. Weight is 32768, the default value for the locally originated message. And the path value, origin code. Okay. So originated from IGP. Fine. So star indicates it is the best path, sorry, valid, and greater than symbol indicates it is the best path. Okay. So R3 has a PGP entry. This is what the entry. Okay. So this route was originally originated locally. So not, it is not learned from any other autonomous systems. So that's the reason default weight is provided. Fine. This is the best path and this is the valid path. And to say the same thing, the network default value. So these values can be three different values, I, E, and question mark. I for IGP, E for EGP, and question mark for unknown. Okay, or incomplete. Right? Cannot, if the PGP cannot verify the availability, in that case, question mark will be provided. So now we'll see the PGP routing tables from the routers, two routers, R1 and R2. So R1 and R2. Okay, so the first one, R2 is the routing table, PGP table is provided. Fine. So the show IP, PGP are given on R2. So the what is the router ID? The router ID is 192.168.22.1. This is the local router ID, R2's IP address. So it has received the route from 192.168.33.0. What is the default mask? That is 20/24. So it is from, which is from 172.16.23.3. So this table is having the valid route and it is the best path. Okay, it is the best route chosen. The metric is 0, the local preference is 100, and the weight is 0, and the path is I, autonomous path. That is provided, path is provided as I. Okay, so R2 will be using this particular IP address as the next stop in order to reach this router. Say for example, R2. This is the neighbor R3. Okay, in between you have something Rx. Okay, so this will be the next hop to reach to this particular router. So what is the router address? 192.168.22.1, and the next hop address 172.16.23.3, and R3 address is 192.168.33.0. So if R2 wants to reach R3, to whom it should contact, the next hop will be Rx. This is the IP address. Fine. So we'll see R1. R1, the PGP entry. Again, we are using the same thing. PGP entry, it is installed in the routing table. Okay. So what is the IP address? 202.165.201.1. Fine. So this is the neighbor, PGP neighbor. Next hop, the metric is 0, local preference is 0, weight is 0, and the path is 6500, and it is learned from I. Fine. So this says it is a valid path, and this one is a best path. From R1, you can say this is the next hop. Okay. So the autonomous path is given as 65000I. So this means the route is originated from autonomous system number 65000. So the routing table entry, that's the reason it is provided like the 192.168.33.0/24. It is 200 slash, sorry, 20/0. Okay, that is autonomous AD20, and the metric is 0 for EPGP. So it is via this particular address, and this is the up and down time. Fine. So R1 is originating the prefix. So what is the prefix? This is actually the prefix 192.168.33.0/24, and it is advertising via EPGP. So R2, it learns the prefix from R1 and it installs in the routing table. Okay, then it says that is the best route and it is a valid route. So this is how the PGP we can verify whether the connections are, sessions are being complete. Okay, any doubts? Any doubts now? Do you have any doubts?
No, ma'am.
So there is a problem. So I have R1 autonomous system. The router R1 is a part of autonomous system number 65100. So it is advertising the network that is one, uh, saying, for example, I'll take. So R1 is being configured in 65100. There is a configuration route. Okay, network 209.165.200.224. Okay, and the mask is provided. So /27. I'm taking this as /27. Why? Because at last you have 224. Only one bit is left. So out of so this is 8, 16, 24. Okay, so 255, 24, 31 bits. So 4 bytes I'm taking it off. So last three things is part of this particular network, that is 24 plus 3, 27. Okay, so it is a R2. It is a part of R2. R2's IP address. Okay, by default, R2 is having passing the same PGP update to R3 without changing the next hop. Okay, so in that case, R3 will receive the route with the next hop equal to, what is the next hop value? The next hop value will be set to the R1's IP address. So what is the R1's IP address in this case? So it is 209.165.202.129 will be the R1's IP address, right? So without changing, the next hop will be set to 209.165.202.129. Okay, so 130 will be R2 address and R1 address is 129. So what happened to R3? If it is not changing the IP address, next hop is not being changed, the same thing is being advertised. What will happen? R3 will know there will not be any direct route to reach to this particular router. So it is connected via R2. So if I'm not changing the next hop, when R2 passes this information, what will happen? Whether there is a direct link between these two things? No, right? So R3 cannot reach the prefix. Okay, so unless special configuration is applied. So on R2, which command we have to use? Instead of network, we have to use the neighbor command. So this is step one. So step two, what we have to do? In R2, we have to use the neighbor command. So neighbor, which is the neighbor, 192.168.33.3 is the next neighbor. And next hop. So I'm being the next hop. So it should say I'm the next hop. Okay, so this will tell R2 to replace the next hop address with its own IP address when it is advertising the routes to R3. Okay, so this is what, when it is advertising any particular route to the R3, it will replace the next hop IP address with its own IP address. So now R3 can see what is the next stop. So what is the next stop? Which is the next stop? Next stop is this particular address. Okay, if I want to reach to R1, this will be my next stop, which can be reachable. Okay, without next stop shell, IPGP peers will not may receive unreachable network hops. Okay, so the next hop shell will ensure internal routers. So always it will be using the route border router to reach the external destinations. So this is actually the border router, right? So it will be avoiding routing black holes inside the autonomous systems. So from R1 to R2, it is ePGP exchange. Next stop will be is ePGP, right? Which will be the next stop. Next stop of R1 is R1's IP address itself. From R2 to R3, it is IPGP, right? IPGP exchange. The next stop, which is the next stop? It should be changed. So before this, it should be using the next stop self message on R2. Okay, so the next stop shell makes R2 responsible for forwarding the traffic towards the external sources. Fine. So this is mandatory. So R2's entire PGP table is provided. There are three entries. That is 192.168.22.0. It is locally configured. Why? Because the next stop is 0.0.0. And we have 192.168.33.0. It is learned from this particular IP address. And another one, this is actually the one which is learned from this particular address. That is from R1, from the autonomous system number 65100. Okay, this is the R1's IP address. So it is ePGP. Okay, in this case, it is IPGP. It is learned from R3. This is the R3's address. Fine. So problem without next stop, what will happen? So when R2 advertises the network, these informations to R3, what will happen? R3 will receive the same message. The same message will be received, right? Together with the next stop is 192.9.165.202.129. So this will be the R1's IP address, fine. So R3 will not have any direct route to connect to R1 interface. So this becomes unreachable network or it becomes a black hole. In order to fix this problem, what we have to do, we have to configure the neighbor, that particular neighbor as the next stop shell. So whenever it is exchanging certain information, it will be replacing the next stop value with its own IP address. Fine. Any doubts? So the default behavior will be IPGP will not exchange the next stop of external routes. So what does the problem happen? Internal peers will not get the unreachable, will be getting the unreachable next stops. This can be avoided with next stop shell message. Okay, so broader routers information will be replicated. So it becomes the forwarding point for the external routes. Right? So now we'll see R3, what happens to R3? R3 has learned some information, right? It has learned this information. From where? It has learned from R2, okay, via IPGP information. The next stop in this example, it is R1, right? So this is the R1's IP address. As you can see here, this is R1's IP address. Okay, so this is indicated with a valid one, but it is not the best one. Okay, so the best path indicator is missing for this particular route. Okay, so R3 will try to validate if the next hop is reachable. This hop is reachable, whether there is a direct link in that. So running uh, IP address, it will be connecting to this particular IP address. So there will not be any direct link. Network will not be, the table information will, the reachability will not be there. Why? Because it is not a direct link. Fine. So since R3 cannot reach the next hop, the route will not be installed in its routing table. Okay. By default, R2 does not change the next hop when it is trying to advertise any of the ePGP routes to its IPGP peers. So R3 will reach an unreachable next hop. This will become an unreachable network, right? So it leads to routing failure or it becomes the black hole. It can be avoided with the help of next option. Okay, so R2 should be configured with the next stop so that this will be reachable. So this is what after making neighbor, this is the neighbor next option. Okay, so it is telling that R2 is forcing to advertise itself as the next stop when sending the message updates to R3. So now if you see on R3, see here, the next stop value was changed here. So in the previous slide, when you compare with the previous slide with this slide, the next stop value is changed here. Okay. And this also changed to the best path. Okay. So this is valid information and also it is a best route. The route is selected as a best route. Okay. So the route is successfully installed. This will become the next stop. Fine. Administrative distance. Everything is provided here. Fine. Any doubts? Any doubts? Students, do you have any doubts? Are you there in the meeting? Any doubts?
No, ma'am.
Okay. How many commands we have seen in today's class? Can you please list out the commands that we have seen in today's session now? Neighbor. Okay. Neighbor command, network command. Fine. Then what else we have seen? How to configure the autonomous system to the neighbor? Sorry, to the router. How to configure the autonomous system to the corresponding router? Huh? That is the first command we have seen, right? What's that?
It is neighbor, then IP address, then remote hyphen AS and autonomous number.
And I'm asking how to set the autonomous system number to a particular router. Which command will be used?
Neighbor command.
First, initially, you have to configure the autonomous system number, right? So, which is the command that will be used? Router PGP, the autonomous system number.
Ah,
Okay, this is actually the first command that we have seen.
first.
The next command we have seen is neighbor. The neighbor IP address remote as the autonomous system number. This is the second command that we have seen. Okay. So in order to verify, how many commands are there? To verify, we have seen
Show
three commands.
IP BGP summary.
Yes.
Show IP route
First one is show IP,
BGP summary.
PGP, show IP, PGP, summary. And even you can use show IP, PGP, neighbors. If you want to see a specific neighbor, in that case, neighbors, the IP address. This is for verification. Okay. So these four methods you can use. Show IP PGP, or else show IP PGP summary, show IP PGP neighbors. For specific neighbor, if you want to list out the details, if you want to see the details of a particular neighbor, if you can use show IP PGP neighbors. Then we have seen network command. Okay. So first router PGP autonomous system number. Then we have to configure the network neighbor in order to verify whether the session is established successfully. That can be verified with these four commands. Then we have seen network in order to inject the IP address from the networking table to the PGP. Then it can be done with the help of network. Okay, there is a problem with that. Why? Because if a particular router advertises it without changing the next stop as its own IP address, the problem comes there. It can be done with the help of what is the command for that? At last, we have seen one command. What's the command? It can be resolved using which command, ma? What happened? Neighbor. So, next of shell. Fine. Any doubts? How many commands we have seen then?
No, ma'am.
How many commands we have seen? Totally, we have seen 8 commands. Fine. In today's class. Please go through that. Check it out whether the quiz is enabled, whether you can access the quiz.
Yes, ma'am. We are able to.
Okay. Complete the quiz. Please post the status in the chat box and then leave the meeting. Please immediately don't leave the meeting. Complete the quiz. Provide status in the chat box and then you can leave. Okay. Thank you, ma'am. You can leave the meeting. Okay. If you've completed, you can leave the meeting. Thank you, Shiv.
Thank you, ma'am.
Thank you, ma'am. Okay. Thank you. Can I try to complete the quiz? Make sure you everyone completing the quiz. Why? Because the consolidated mark will be taken quiz 3. Okay, complete the quiz. I'll end the meeting. Make sure you're completing the quiz. Right? Thank you.